In this video, I'll solve a problem that uses the empirical rule. So let's just go over the empirical rule quickly. What it says is that if you have a bell-shaped distribution, and by bell-shaped what we mean is that it's unimodal, there's only one mode, and that it is symmetric, roughly symmetric. It doesn't have to be perfect. So what this empirical rule tells us is that if the mean we have at the center here, and if we take the mean plus one standard deviation and mark that spot, and the mean minus one standard deviation and mark that spot, then between those two values, we are going to find 68% of our data. So for a bell-shaped distribution, you have a lot of data concentrated really close to the mean, is what that's telling you. The next part of it says, what if we go out 2 standard deviations from the mean? So if we go from 2 standard deviations below the mean to 2 standard deviations above the mean, now we're talking about having 95% of the data between those two values, which is almost everything. That's just leaving us 5% left over. And finally, we go out 3 standard deviations. And once we do that, anywhere from 3 standard deviations below the mean to 3 standard deviations above the mean, that means we're capturing roughly 99.7% of the data. So not quite 100%, but definitely more than 90, well, I shouldn't say definitely, but most likely more than 99%. So now what can we do with this? What we're going to do is solve problems based on this information. As long as I know the mean and the standard deviation, then I can construct this distribution, and then I can make certain statements about the distribution. Okay, so in this problem, we have some information about the distribution. We are given that x bar, it says here, but this is from the calculator. So since they're telling us in the problem this is a parameter, it's not really x bar, it's actually mu. So I'm going to put that down here. Mu equals 158. They give me some other information, and they tell me the sample standard deviation. Well, we're working with population, so I'm going to simply ignore that. And I'm going to go with the population standard deviation, which is 6. Okay. So that is 6. All right. So now what I'm going to do, all right, so now what I'll do is I will solve this problem. It says, assume the population is bell-shaped. Okay, so we've got our bell-shaped distribution. Now I've drawn my bell-shaped distribution. I've marked the mean, and the mean plus 1 standard deviation, plus 2 standard deviations, plus 3 standard deviations, and then 1, 2, and 3 standard deviations below the mean on the axis. So I really am not using this portion of the distribution. I need to know that the distribution is bell-shaped, but I don't actually have to draw this portion of it. I really just need the number line. You're going to see I'm just looking at the number line for this problem. And I'm going to use my mean and standard deviation to label this axis. So the mean is 158. And I've labeled the mean in the center, and then I took 6, which was the standard deviation. I added it 3 times to the 158 to get 164, 170, and 176. And then I subtracted it 3 times. So the first time I got 152, 146, and then 140. So now what I know from the distribution and the empirical rule is that, and my question here is, what percentage of values fall between 140 and 176. So here's the 140, here's the 176. And that's 3 standard deviations away from the mean. 3 going this way, oops, and then 3 going this way. So that means that we're talking about 99.7% of the data is between 140 and 176. Now, occasionally your textbook will, instead of being so specific to say 99.7, they say all or almost all. So if that's the choice, then go ahead and pick all or almost all, which means exactly the same thing to the book as 99.7%. In part 2, it asks, assuming the population is bell-shaped again, so we're still working with that empirical rule, between what 2 values will approximately 68% of the population be? So now we're looking at 1 standard deviation below the mean to 1 standard deviation above. And that would be 152 to 164. So that's the answer for that part. So for the first part, we got 99.7%. And for the second part, we got 152 to 164. Now in part 3, it asks if we do not assume that the population is bell-shaped, at least what percentage of the population will be between 146 and 170. Okay, so now I'm going to take away the bell-shaped portion of this. So no more bell-shaped. So there's some kind of distribution going on. I don't know what it is. We don't need to know what it is. What I'm going to use when I don't know that I have a bell-shaped distribution, or if I know what the distribution is, but it's just not bell-shaped, then what I do is I use Chebyshev's rule. And what this says, it tells me that 75% of the data are between mu minus 2 standard deviations and mu plus 2 standard deviations. So this would be at least, I should say, squeeze that in there, at least, because we don't know the distribution. But what Chebyshev found was that no matter what the distribution is, because you're calculating the standard deviation and the mean from that data, that if the data is very spread out, that's going to make your standard deviation larger. So it's still going to work that at least 75% of the data are going to fall between minus 2 standard deviations and plus 2 standard deviations. So that's an at least, not like the empirical rule where we're saying that's pretty much what it is. It's an estimate still with the empirical rule, but here we're just saying this is the minimum that it has to be. And then 88.9% of data, at least, are between 3 standard deviations below to 3 standard deviations above the mean. And so this is 88.9%. Okay. And again, just remember, that's at least. So in your problem, it says, if the population is not bell-shaped, at least what percentage of the population will be between 146 and 170? Okay. So now I'm going to go look. And what do we have? 146 to 170. Well, that's 2 standard deviations out, so that would be 75%. And that's all we have to do for that. Now in your textbook, they give you a formula for Chebyshev's inequality. On the exam, I'm just going to tell you 75% and 88.9% because those are the only 2 that we ever look at. So it's not really necessary to learn a formula. We're not going to use this again this semester. So it's just to give you some information about what distributions are. So don't worry too much about Chebyshev's rule. And then the empirical rule, we're actually going to learn how to calculate that a little bit more accurately. So that's not going to be super important, but it's part of your foundation. So that's why we cover that. And that's how you do that problem.